All right, greetings and hello. Today I have a technical deep dive to share with you on the topic of how to use SSH CA signed certificates for Linux systems authentication. So this tutorial is intended as kind of a foundational exploration rather than a production-ready implementation example. There is software out there that can make this type of SSH certificate usage much more user-friendly, but this is more of a close look at kind of what underpins some of those implementations. We're going to take a close look at SSH CA signed certificates for authentication as implemented directly with the OpenSSH utilities that we're used to, like SSH keygen. Let's see here. So we're going to start with an overview of just kind of SSH public key authentication generically, and then we're going to compare that public key approach to SSH CA signed certificates. And finally, towards the end, we'll dive directly into a demonstration showing how to use these signed certificates, and as well as the key revocation list, or KRL, that's provided by the OpenSSH setup. All right, so first off, a bit of information. This page up here, memblin slash demo dash SSH dash certificate auth. I've got some container files in here, some documentation about how to use them. This is basically how I produce the demo that we'll be jumping into later. So if you want to play with some of these concepts yourself, the containers that I'm using are in here, and then this demo file contains the actual copy-paste snippets that I'm running for the demo later. All right, so let's get on with public keys, right? So for public key authentication, we create a public and private key pair. We use SSH keygen to do it. We set our type. I'm using ED25519 here. You've got RSA, ECDSA. There's several types that can be put in here. I provide a comment. Usually I like to date my comment. This specifies what file I'm writing to. And in this case, this is telling it to not ask me for a password. That's generally bad form, but for the demo, pretty much all of my private keys are going to be unprotected. So whenever you run this, you create the private key and the public key as a key pair. This is an example of what would be in the public key. And then you can collect these public keys, like for each user, and deposit them in authorized keys files on target servers to enable access to those users. A lot of us are already familiar with this type of access, and it's one of the first types of non-password authentication access that I was ever introduced to. Right, so let's see here. With this public key type of access, it should be noted that the public key has to be written across all servers that the user should have access to, right? Not only that, when they're being written to the authorized keys file, that authorized keys file is for a specific user. So if a user has remote access to multiple users on a target server, each one of those users on the target server is going to need its own authorized keys file with a copy of the public key available in it. All right, let's see here. So as you can imagine, managing that kind of public key distribution and rotation across a large infrastructure at scale has quite a few drawbacks. Issues are seen in those general areas of key distribution and rotation quite commonly. And while we could create automation to kind of manage and wrangle all of those needs, I've typically seen those types of systems grow to be fragile and rather difficult to manage. Typically, I've seen them become somebody's pet, so that you've got one or two people that can manage those types of automations, and when they're out, the system ends up actually being at risk because no one knows how it works. Now, that said, centralized user management systems like Red Hat IDM or FreeIPA, its upstream variant, or even Active Directory can provide some enhancements to that public key authentication approach. And while it does enhance their usage by meaning, like you don't have to copy the public key around all the time, you just put them in the central system, there is still risks and management burdens associated with, public key rotation that must be forced. Let's see here. So the certificate concepts that we're going to be exploring here, I believe they can be seen as replacements for or augments to the common public key authentication that we're familiar with for SSH. I'm going to scroll down a bit here. So we start exploring SSH CA signed certificates and how they work. When using the signed certificates, first off, as I had mentioned, we don't need to copy the public key around anymore. We do have to distribute the CA keys that we trust, but that's a different thing, right? It's not tied to a specific user, so if that user is no longer allowed to access our infrastructure, we don't have to rotate to CA. I also want to note that OpenSSH supports the creation of simple certificates and the associated CA infrastructure. These are not X509 certificates, to be clear. You can see two of them here. And I want to point out that there are two types of certificates in play here, right? We'll be able to see in this example, this top one is a host certificate. It pairs with the host key to provide the identity for the host itself. Specifically, you can think of this as the host key, right? The same kind of thing that when you SSH to a machine for the first time, it pops up and is like, hey, the identity is unknown. Are you sure you want to trust this key? That trust on first use negotiation. These host certificates are to kind of help add a bit of a trust in advance for those types of keys. Now down here below that we have an example of a client certificate or a user certificate. All of the certificates have like the public key, some identity information, validity constraints, basically just how the certificate or what the certificate is allowed to authorize on the remote hosts. Let's see here. These the format for these certificates, it's very well covered in this particular file, and I have a copy of this file, but I'm going to bring it up on my machine here. User share doc OpenSSH protocol.cert keys. Yep, I believe this file is on any Linux machine that has OpenSSH installed, and it's the one we're about to go through here in this web browser as I scroll down. This is a document that I had to come back to several times when trying to figure out how all of this worked. Like the blogs would reference a certain thing, but maybe the syntax didn't quite meet what I needed or I wanted to know more. This particular file right here is an excellent resource for figuring these things out. It dives into like code level specifics about the certificates, the different types of certificates, and what they look like. It's got more information about like how the validity, like valid principles are used, and just generally a deep dive into everything. This is where I found that it looks like we could make a certificate only good from specific source addresses. I thought that was kind of neat, though I haven't explored it yet, and we don't dive into it in this demo. But this particular protocol.cert keys document, keep it at hand while you're learning this stuff. It's going to help you out quite a bit. I'm going to scroll back up to the top here. Got some more config snippets. Now, this the SSH service configuration snippet. So what I'm talking about here is that the trusted user CA keys variable here, or parameter, points to a file on disk that has a list of trusted SSH CAs, right? which look very much just like a public key. That's because that's what they are. And once SSHD has been told to trust keys from this CA, we can attempt to log in with a certificate that was signed by this trusted CA, and it should allow it to work once the configuration is good. The other half of that, right, is having the client trust the host certificate and its key. I mean, that's done by adding a line like this to the user's known host file that will be operating that client, right? So much like whenever you accept that trust on first use key, it would end up in this file. This is the same file with just a little bit different format. We say, yeah, it's a cert authority. This is the domain that it is valid for, or that should be checked against. And then this is the key that would do the validation. And this is our host key rather than, or the host CA rather than the client CA. Let's see here. All right, so that's kind of the big points of the configuration and the bits of that we're going to bring together in the demo. I haven't shown the KRL here. It's another piece of this, but we'll actually cover it in the demo itself. We'll bring in another trusted, or not a trusted, but another SSHD configuration parameter to handle that. Let's see here. Now back to the demo on this side. All right. There we go, our terminal. So I've got 3 containers spun up here. These are the Alma Linux 10 containers out of that repo. They are systemd containers that also run SSH. So they're a little different than what you would expect to see in a normal container that just has one process running. But this lets me test exactly what I want to show here. I'll also show you that we have these 3 users that I've added in. They don't have passwords attached to them. Yeah, because we're going to be using these certificates to actually access those machines. Those users exist on all 3 of these containers. And that's important because while we list principals right here, in our certificates, like this certificate allows access to these 3 principals. The users that map to these principals must exist on the target system already, or it won't allow authentication at all. So like if the user doesn't have a role A, even though role A is permitted by the certificate, the user or the system is going to be like, hey, that user doesn't exist. It's not going to let you in there. It's not going to try to create the user on the fly for you. It still needs to know that it exists. Back to our consoles here. There we go. So I've got the 3 machines. The top one is our CA. It's kind of just like the lab box we're going to be SSHing out from as the source of our SSH client connections. And then test 01 and test 02 will be like remote servers that we'd be accessing with these credentials. So the first thing I'm going to do is I need to go ahead and create a user key pair for root on the CA machine. Standard key pair, private and public key generated from that. Now I'm going to create a directory to keep our SSH CAs in. I've changed the directory into that at the same time, and now we're going to create the client CA, that's our user CA, and grab the host CA as well, paste that in there. Now we should have both of those files there. Excellent. Now we're going to populate the known host file for the root user. Part of this command here cats this host CA pub key so that it ends up in our known host file. I'm going to show you what the full content looks like once it's been manifested there. Here we go. So this tells my root user's SSH client that host keys supported by host certificates from this host CA are trusted. So whenever I SSH to a target machine that is serving one of those certificates, I should not get the trust on first use prompt, this prompt right here. Yeah, the authenticity of host cannot be established. Do you want to trust it? I'm going to say no, because I want this prompt to be able to come back up again if we're configured inappropriately. But what should happen once we're configured properly for host key trust is it will pass me directly on through to a password prompt, assuming that we don't have certificate trust on the server side already taken care of. So our host client is set up. I'm going to cat our client key because we're going to need to deploy that onto our target host so they know what CA they can trust. First thing we're going to do is export this value just to make it easier to work with on both of my target machines. Then I'm going to echo that content using the envar into a new file right here. There we look good. Now we're going to use a here doc syntax to extend our SSHD configuration. We're writing to this file right here. Awesome. So that points SSHD, trusted user CA keys, to this particular file, which contains our one and only current client CA or user CA. I had mentioned before, I believe, that this file can contain multiple CAs, like if you wanted to do a distributed CA of some type. But all CAs mentioned in that file would be able to produce keys that are trusted, or certs that are trusted. There we go. So let's get that in there. Now we need to set up our, or get our host keys so that we can sign them. We're going to have to bring these back to the CA because the public key that we'll use for signing resides there. Alright. So first we'll take care of test01. Oh, I missed something. Oh, I missed our host keys directory. Let's create our host keys directory first. And then we'll bring that host key over. There we go. So that populated that file for test01, and then we're going to do the same thing for test02. Beautiful. Both of our host keys are local now on the CA box. Now we're going to sign them. This is saying my key ID is this. This should be like the canonical name for your host. This is the SSH CA that we're using for the signing. This says it's a host CA that we're doing the signing with. This gives some valid principles that this host might receive connections as. Valid for 52 weeks. Why not? It's a host key, year long. Let's go. And then the public key that's actually getting the signing, right? This is the host public key for the type of key that we're signing, the CD25519 key. So run this. It's going to output that, hey, we did the signing. And we can see that this is the file that it produced. I'm going to sign for the other hosts now. Paste that there. We can look at these files to show that they were generated properly. This is the SSH keygen output. They're very similar, just like our examples. I'm going to cat the contents of these keys, or these certificates rather, because I need to drop each one of these back on the host that it came from. All right. Got a little extra on that one. Drop our host key in place, or our host cert, signed cert in place. Same thing for host 2. Get this exported. Now we're going to write that to the same file on each host. Should be a little different content. Now let's make sure the content copied correctly. Test 01, we're good. We're good. Now we're going to extend our SSH config again. We're adding the host certificate declaration and parameter. This just says, when you're serving up your host key, also serve up this host certificate. And with that, we'll restart SSHD on both of these. And we're going to start some logging. Actually, I want to fix this thing here. This causes some weird errors to show whenever we're browsing these logs. So I just comment out the PAM systemd here. And we shouldn't have to worry about that popping up in our log output, confusing things. All right. Boom, just ask for a password. That shows that we're getting past that trust on first use negotiation. I can bring it back by removing part of our configuration, right? Our known hosts on the client side. If that's not present, we still get the tofu ask. Pop it back in there because we went off with certs. There we go, back to that. Now it is asking us for that password, but that's specifically because we haven't signed our certificate for authentication yet. We're going to do that. First off, I'm going to issue let me back up one directory here. Okay, there we're in with that. This is the command to sign my or root's ID ED25519 public key for 15 minutes of validity for the root principal or the root user on our target server with the SSH client CA, and we're going to pass the identity or ID, the certificate of admin-user. Again, that field is kind of free form, and it should represent the actual entity using the credential. Like that's what that ID is for, and you'll see it in these logs whenever I use it to access the machine. So we've got our signed cert, right? I look in here, you can see it created the cert. We can actually examine that cert the same way we did with the host cert, and we can see that it's got the metadata up here, our key ID, which will show up in the logs, our validity for 15 minutes, the principal allowed, just root, and then these extensions, like you can turn these on and off whenever you're requesting the signed certificate. So maybe you want a certificate that doesn't have any of the forwarding enabled. We can do that. The critical options that we had seen earlier in that documentation file, that's where you could also request during key signing limited source address so that the certificate would only be accepted from a particular source address. All right. So let's go ahead and I'm going to load up an SSH agent. Show the keys that are in it, or none. And now I'm going to load my key. When I do this, you see that it loads my private key, and then it also loads the public certificate that's associated with it. And if I SSH add -l, I can see both. Oh, man, that's interesting and fun. So now when I SSH to root at test01.local, it's going to use the keys from my SSH agent, and it should drop me right in. There we go. I'm in. And our logs, right? Accepted public key for root from what IP address. We've got some SSH certificate information here. We've got the ID, right? That's good stuff. The serial number included. If the system that was managing our cert signing was rotating certs and properly managing things, we would probably use that serial number field. But the raw OpenSSH tooling doesn't use it by default. You can specify it. It's just not. Yeah, it's just not used by default. The system consuming this would be able to use that. I can exit out of this. Actually, let me pop back in there. And so you can see there's no authorized keys for this user. There's nothing in here. This is 100% just, hey, I trust that CA, let him in. And I can do the same thing for test02. See the same thing, accepted public key for root for the admin user. Now, we can also ask for signing with different restrictions, right? I had mentioned that one was for root. If I sign my key and tell it only CA user and only role A, then this key will no longer be able to access as root. Now, one thing I noticed in prior testing was that this key right here, this is still good. So if I go ahead and add the updated certificate to my current agent, I get 2. And this impedes testing because this one has root still in it and this one does not, right? But if I go to authenticate right now, it will still allow root because it's going to see that other key through and through up until that 15-minute validity period when that key expires, right? So let's see here. We did see this one also said, hey, in this other certificate, you don't have a valid principal, but the first one it did check out. So what I'll do is I'll just go ahead and exit and then relaunch my shell in here. And then I'll launch a clean SSH agent. All right. And load my keys up. List them, and we just have the one. Now I should be directly and actively denied. Yeah, it's like, hey, need a password. And if password authentication was disabled on the remote side, I do believe that authentication would just fail. It would just be like, did not go through. It wouldn't even ask for a password. Same thing there. So, all right. Now, I had mentioned you can generate those keys and turn off specific SSHD subsystem things. This is a command that would do that, right? Option no port forward. Option no X11 forwarding. CA user role A. 15 minutes, right? Let's pop that in there. Take a look at it. All right. And we can see that those extensions that were there before, they're missing now. It won't affect us in what we're testing here because we're not using any of that forwarding, but just something to know exists. With this key, I should be able to access as CA user. Yes, we can, and we see again, CA user accessed from this IP by the admin user. Doesn't even have a .ssh directory, so definitely no authorized keys file. And this role A user. Right in. Same thing for 01. Yep. Awesome, good stuff. Now, a lot of what you've been seeing me do is create short-lived keys, right? That's populated, so let me exit out and launch a new one. I guess I could probably just kill it, but I don't want to have to look that up right now. Let's see. Now, I'm going to write an exceptionally short one, so we can just sit here for a minute. Paste all of my users except relay, and let's say good for 1 minute, right? Now if I go ahead and populate that, I better hurry, gonna run out of validity time, right? Alright, we've added it. We only have the one. Alright, and we're here. Now if we let this minute burn, just let it keep on going, may still be able to get into 2, but as soon as we hit that time limit, it should start denying us, even though we still have the exact same key, right? Validity 20 date. All right, now that ought to do it. There might be a little clock skew, but we'll see. Yep, boom. Certificate expired. And again, ask me for a password because there we go. So that's what happens when the certificate itself actually expires. It wouldn't boot me back out of the machine. At least not to my knowledge. I haven't had that happen yet. It just won't allow reconnection once that session has been shut down. Now, if you were to start issuing really long-lived certificates, right, then you run into a problem where that certificate is good, is valid for access for as long as the target trusts the issuing CA, because it's just an encryption check that's going on, or for the total validity time of the certificate. So if it's 52 weeks, that certificate is good for 52 weeks, period. The only thing to work around that is the key revocation list, or KRLs. Now, the key revocation lists are used to disable a certificate that's been issued before it has expired. And I believe it can be done by key ID or by the actual public key itself that's being used, that's being signed. Let's see here. I want to touch on anything else. I think we can probably just dive right on into it, right? As a recommendation, most SSH certificate recommendations that I've seen in blogs and in docs here and there, they all recommend a very, very low and appropriately scoped signed key for access. The short validity time ensures that the certificates will only have access for a short period, and that if that leaks or perhaps staffing changes happen, whatever it is, you don't have to worry about it too much. So having that short TTL allows work to be done with credentials that were created kind of like just in time and specifically for the task at hand. Now, if we had policies that were able to enforce that type of TTL, that prevents the need for distributing the KRL or key revocation lists that I'm about to show you how to create. And that list basically has to be sent to all enrolled SSH targets, right? So if service or if a server is being managed, let me try this again. If a server's authentication is being managed with certificates, then short TTLs, not a big deal. Long TTLs, you've also got to ship the KRL along with it to be able to jump in at any time and disable a key that may be available that shouldn't. All right, the first thing we're going to do here is we're going to create an empty key revocation list. There we go. This is on our CA box. This is just where it's going to live. And I'll show you what's in there. Not too much. We've got a version which we did go ahead and put like as a serial number kind of. And then I'm going to sign a very long-lived host key or client key here. Admin user, root user only, same my public key, and I'm giving it 52 weeks, right? Now we can look at that public key, I believe. Where's my shortcut snippet? There it is. We can see that this should indeed be principals root only, and 2026-04, 2027-04-04. So 52 weeks. I have a cert in there still, so I'm going to jump out. Good. All those SSH agents. I'm going to have to find a better way to handle that. I know we can just delete the key. I just cannot remember the syntax right offhand, and I don't want to slow down for the demo to figure it out. Now we've added that public key. We only have the one. We can access our machines. Root, admin user 1. All right. So that's working, and it is a long-lived key. Now what we want to do is distribute this KRL to our hosts. I'm going to do that with SCP. We already know that we're allowed to both of our hosts as root, so that'll let us drop these files wherever we need. We're going to drop them into the etc SSH directory. I'm going to pre-expect it path and name. Then on each of our hosts, we're going to configure them. I'm breaking my logging on both, pasting in a here doc to populate the revoked keys path variable or parameter, using that same approach that we used earlier. Paste that here. Now we'll restart SSHD on both of these machines and pop back into our logs. Alright, now we can still access these machines. We've got a full year-long certificate, right? I was wondering why it wasn't logging. There we go. It was just scrolled up a little. So that's working. Now, seeing that it works, we're going to go ahead and add that admin user to our key revocation list. So we're revoking this key, or this certificate. If I look at our revoked key, or KRL now, it's got it in there. Now I'm going to sync those to our target machines, because like right now, I can still access them. Right? Totally. local, easy peasy. But that key is in our KRL. This is what I meant. We have to manage the distribution of the KRL to all the machines. Thus, using long-lived certs like this really turns up the management burden on authentication for this type of work. Let's distribute them, and as soon as they land, we should be blocked. Oh. And oh. Still asks for password because other authentication methods are allowed on this particular server, but it failed because our cert was revoked, as you can see on both. All right. I think that's just about it. With that, we've covered several topics from SSH CA types, host and user or client, how they're created, the client or user key signing and the SSH deconfiguration portion of that, host key signing, and how the known host configuration gets updated to trust the host CA, and then a brief touch on those key revocation lists. To make like all of these concepts more production ready and automated, one would need to produce a system that could provide like upper tier authentication and authorization for key signing so that a user could only request the principals they're allowed to, right? Um, then like a automatic, like a non-SSH based distribution of the CA public keys that servers should be able to trust, and maybe even the KRL file, making those available without having pre-distributed SSH credentials in place to have it, like maybe having them in a pull way. That could help, so that it's not as difficult to get those trusted CA values in place around your system. Um, One could also supply, as I mentioned earlier, like multiple client SSH CA options, perhaps as a distributed organization or team managed CA cert request type of design, that could have, per team policies applied to it and have each team manage things independently. May not be a good idea, but something that dawned on me, along with like instead of provisioning users as local users on the boxes, but use those local users as roles. So a local user on the box may have specific permissions, group membership, sudo rules, right? All kinds of things that you could then allow a set of users to access through these certificates by allowing them to access that specific principal that has those elevated rights. Um, let's circle back to a few other like external things. I wanted to point out that Fedora has a really good set of documentation here that I stumbled into later. It was kind of after I'd walked through this several times, and they seem to have pretty much everything I've covered, really well done in depth from the Fedora perspective, but it at a cursory glance should apply to pretty much any popular Linux distro that's shipping with OpenSSH right now. And also, I want to mention other systems that I found that have some sort of SSH CA built into them. And one right off here is HashiCorp Vault, right? It's got two options in here with the SSH secrets engine. Signed SSH certificates, I have taken a cruise through. It's basically what we've done here, but they don't provide KRL integration. At least I couldn't find a way to do it, and I see some issues on their repo where other people have asked for it. Vault instead is saying, when you make your certificate signing requests, make the TTL short so you don't have to worry about KRLs. And that's a valid way to look at it and something that you would need to consider if you were using Vault to do that integration. The neat thing about this type of integration is it's the same type of configuration on the OpenSSH side, but you can provide policies for your users so that they log into Vault and then they are restricted as to the OpenSSH signing they're allowed to request. Like they can be restricted for default extensions, they can be restricted for principals that they're allowed to access, and all of that can be restricted by standard Vault policies that you're already familiar with if you're using Vault. And then like getting the key signed, this is like a CLI version of what it looks like. It can be done with the API as well. You would, run this, and that should output the certificate that I was generating with, I don't know if I have the command here, but it would basically, it's this certificate right here being issued from that Vault operation where you write to that endpoint. So Vault is worth a look. If you don't want to roll your own automation around this type of authentication management, and there are other systems out there as well. But that's pretty much all I wanted to cover. OpenSSH authentication via CA signed certificates. Go, go. With that, I'm going to wrap up. I hope you've enjoyed the content, and thank you very much for watching. Have a wonderful day.